So if the Pascal's triangles trick wasn't cool enough, there's an even cooler trick that you can use. This involves using a process known as combinations. Combinations is a mathematical term that comes up with all the possible combinations of a set of numbers based on certain criteria. You use this a lot in statistics, but for our purposes, you just need to know the basics. First, in exclamation point just means multiplying all the numbers that lead up to n. So if it was 5 exclamation point, that means 5 times 4 times 3 times 2 times. Then this is how we calculate the number of combinations. So we typically say it in choose R. So out of the total number of combinations, I want to pick a specific number. So maybe I have 5 total numbers in my set, and I want to choose 3 of them. So to come up with all the possible combinations that I could choose 3 of them, I would say 5 exclamation point over 5 minus 3 exclamation point times 3 exclamation, which is 5 exclamation point over 2 times 3. And then you could even say 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. And magically things cancel out. Boom, boom, boom. So you have 5 times 4 over 2, which is 20 over 2, which is 10. So there are 10 possible ways that you can choose 3 out of 5 things, assuming all 3 of those things are different. So how does that lead us to our binomial expansion? So Pascal's triangle is actually a set of combinations. So 3 is going to be your n. R is your other number in the set. So if we're going to expand this out, we would say 3, choose 0, because we're taking 3 numbers and we're choosing 0 of them. We're choosing 0 b's, and then it would be a b. A to the third, b to the 0. Following our same binomial expansion pattern. Then it would be 3, choose 1, a squared b to the first. Then it would be 3, choose 2, a to the first, b to the second. And then 3, choose 3, a to the 0, b to the third. Just a couple kind of hints here. Like your first term is when you choose 0. So you start with 0. With 0. And then you end choosing it yourself. And something like this might seem more complicated than it needs to be, but for something like this, find the 5th term of a plus b to the 7th power. If I only need to find the 5th term, then I don't necessarily need to expand the entire binomial. I really just need to focus on that 5th term. So if we think about it, since we start on the 0 term, like this is technically our first, and then second, third, fourth. if you notice, our first term is when we choose 0. Our second term is when we choose 1. Our third term is when we choose 3. So if I want the fifth term out of a plus b to the 7th, it would be 7, choose 4. It's 1 less than the term number. So 7 choose 4 is 7 exclamation point over 7 minus 4 exclamation point times 4 exclamation point, which is 7 exclamation point over 3 exclamation point times 4 exclamation point, and then 7 times 6 times 5 times 4 times 3 times 2 times 1. We technically don't have to write the 1. And then 3 times 2 times 1 times 4 times 3 times 2 times 1. So these are going to cancel. So you have 7 times 6 times 5 on the top. And then you have 3 times 2 on the bottom, which ends up giving you 35. So that's the term. That's the leading coefficient. Your term would be 35. And then remember your power rules. If you're going to be on the fifth term, think about the fact that you start at 7, and then you decrease 7, 6, 5, 4, 3, 2, 1. So this would be 1, 2, 3, 4, 5. So it would be a to the third, b to the fourth, remembering that both of those still need to add up to 7. Here's another one that's it's similar. Find the coefficient of the x to the 7th y squared term in the expansion 5x minus 3y to the 9th. So I think it would probably come in handy to figure out which term this actually is. And it just asks for the coefficient, keeping in mind that the final coefficient is somehow going to involve the 3 and the 5. So we are 9. If it's x to the 7th y squared, and we start at 9, 9, 8, 7. So this would be our third term. And remember, when we did this previous example, if we know we're on the third term, we choose 1 less than what it is, because we always start on 0. So we are doing 9, choose 2, which is 9 exclamation point over 9 minus 2 exclamation point and 2 exclamation point. And this is 9 exclamation point over 7 and then 2. So we have 9 times 8 times 7 times 6. I'm going to cheat a little bit to 1, because we know that's what that does now. And then this is 7 times 6 times 5 times 2 times 1, and then times 2 times 1. So this 7 times 6 times 5 times 4 times 3 times 2 times 1 will cancel that out. And so you are left with 9 times 8 over 2, which ends up being 36. So you have this. That's important. Now you need to keep in mind the 5 and the negative 3. So in reality, the 5 and the negative 3 would correspond with the 7 and the 2. So it would be 36, 5x to the 7th times negative 3y squared. And so now we just need to calculate your coefficients. We know that 3 squared is 9. And 5 to the 7th, you might not know, is 78,125. And it is quite possible that if you're using a basic calculator, it might not calculate this for you. And this would be your coefficient. Technically, it only asks for that. So you can use this trick if you don't have to expand the entire binomial. Comes in handy, especially for problems like this, where it would have taken you a long time to compute all that. That's all we have for today. As always, let me know if you have questions and make good choices.